Alright guys, we're looking at even more relationships in circles. Talking about some inscribed angles today. So an inscribed angle is an angle whose vertex is on the circle and whose sides are chords. So you can see a picture of that here. There's chords. And instead of the vertex being at the center of the circle like a central angle, the vertex is here on the edge. So we know some things about inscribed angles that are different from central angles. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So the measure of ADB is half of this arc that it opens up to, its intercepted arc. So half the measure of AB. So let's try an example of this. It says find the indicated measure. So we want the measure of angle S here. And if I know that angle is half of the arc that it opens up to, if the arc is 60 degrees, then the measure of angle S has to be 30 degrees. We want the measure of arc QS here. If I know the angle is 37, then I need to double 37, and I get 74 degrees. So a little bit different thinking from central angles. Okay, if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So what I want you to notice is that angle ADB opens up to arc AB, but also angle ACB opens up to arc AB. That's its intercepted arc. So what that's saying is, if we know those, that obviously AB is congruent to AB, so then we know that angle ADB is congruent to angle ACB. Alright, if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle and the angle opposite the diameter is a right angle. That's a lot of wording there. But what this is saying is basically if you have this diameter and then you have an inscribed angle, if it's opening up to that diameter, I know this semicircle over here is 180, which would make this a 90-degree angle. So there's a right triangle when you have a triangle whose leg is a diameter. So the measure of angle ABC is 90 degrees if and only if AC is a diameter of the circle. Alright, then a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. This is different than what we talked about with quadrilaterals. Quadrilateral inside a circle, when we talked about parallelograms, we said opposite angles are congruent. So in this case, opposite angles are supplementary. So the measure of angle D plus the measure of angle F is actually equal to 180, not equal to each other. Same thing with the measure of angle G plus the measure of angle E. They're equal to 180. So an example here then is if we're looking at A, instead of x being 88, x plus 88 is 180. So we would subtract 88 from both sides. So x would equal 92. And we do the same thing for y. Y is not equal to 100. Y plus 100 equals 180. So we subtract 100 from both sides. So y equals 80. We can do the same thing on part B. So 8x and 4x would equal 180. So 12x would equal 180. We divide both sides by 12. And x would equal 15. And same thing with y. We get 3y plus 3y is equal to 180. So 6y equals 180. We divide by 6 on both sides. And y would equal 30. Alright guys, if you have questions, please make sure you're coming in to see me. If not, I will see you in class.